Hi everyone! In this video, we are going to talk about how to graph linear inequalities on a Cartesian plane. So here's some things to remember. When you're working with inequalities, it's so similar to working with equations, but we're going to, of course, use an inequality symbol like less than or greater than, less than equal to or greater than equal to. So that means a major change is that when you are solving an inequality, you may need to flip the inequality sign when you multiply or divide by a negative number. That is the big difference. Now, the way our graphs are going to turn out are going to be very different because the solutions to a linear inequality are all of the points that make the inequality true. So when we're working with equations and we're graphing lines, every point on the line is a solution. But now we're talking about any point less than or greater than the line is also a solution. So our solution set's going to get really large. Okay, so let's do a little conceptual understanding here. Our first set of directions say, determine which of these ordered pairs is a solution to this linear inequality. So remember that every ordered pair always is an x and a y. So if we take 2x minus 3y is less than 15, and we replace the x with a 2 in this case, and the y with a 5, we are going to see if this inequality still comes out true. So let's do a little arithmetic. 2 times 2 is 4, minus 3 times 5 is 15. 4 take away 15 is negative 11. And negative 11 is less than 15. So yes, this is a solution to this inequality. But remember, there are infinite solutions. Any combination that's less than 15 is a solution. So let's check a second. Negative 1 is our x. Negative 7 is the y. Let's put these into the inequality. 2 times negative 1 minus 3 times negative 7. Is that less than 15? Okay, little arithmetic. 2 times negative 1 is negative 2. Negative 3 times negative 7 is positive 21. Negative 2 plus 21 is 19. 19 is not less than 15. So no, this point is not part of the solution set. It is outside of the solution set. Let's keep checking. 3 for x, negative 4 for y. I can put those into the position, positive 3, on the inequality and start checking. 2 times positive 3 is 6. Negative 3 times negative 4 is a positive 12. So 6 plus 12 is 18, and 18 is not less than 15. So this is not part of the solution set. Okay, we've got one more to check. Excuse me. We'll use 0 for x and y. This is the origin. So 2 times 0 minus 3 times 0. Is that less than 15? Well, this is some easy arithmetic. Anything times 0 is 0. And 0 take away 0 is 0. 0 is less than 15, so yes, this is part of the solution set. Okay, let's start graphing. Here's some steps to follow when we are graphing linear inequalities. Step 1, put the inequality in slope-intercept form. That is not going anywhere. We are still going to be working with y equals mx plus b. Here's that note again. Be sure to flip the inequality symbol if you multiply or divide by a negative number. Now, instead of just graphing lines, we're going to have a specific type of line. We're going to use a solid line, as usual, if there is some kind of equal involved. we are going to use a dashed line if there is no equal involved, just a less than or a greater than. Solid is going to represent equality. All the numbers on that line are part of the solution set, whereas the dashed line represents an inequality, so the numbers on that line are not part of the solution set. And then finally, when dealing with inequalities, we're always going to shade towards the less than or greater than zone. So we're going to shade above the line for all greater than or greater than and equal to symbols. And we're going to shade below the line for all less than or less than and equal to symbols. So let's take that same example from earlier and graph it to show you on the graph where these points live and why some of them are part of the solution set and some aren't. Okay, I'm going to switch colors so you can see my graph well. I'm going to graph with this brown marker. So before I can graph, we have to turn this into a slope-intercept form. We should be getting really good at that. I'm going to start by subtracting 2x from both sides. That will leave me with a negative 3y. Subtracting is not a reason to flip the sign, so I'm going to leave it at less than. And now I'll write this in slope-intercept order, negative 2x, positive 15. Now to get rid of the negative 3 that's a coefficient, let's divide by a negative 3. And guys, I hope you are used to that being why we flip the inequality sign, dividing by a negative. So instead of less than, now I'm working with a greater than. Negative 2 over negative 3 cleans up to be a positive 2/3. And positive 15 over negative 3 cleans up to be a negative 5. Somebody really wants to get in touch with me there. Okay, now I'm ready to graph this line. Remember our talk about graphing. We start at the y-intercept, so here I'm starting at negative 5. Oh, gracious. 1, 2, 3, 4, 5, negative 5, with a slope of rise 2, run 3. Now, if I keep going, I'm going to fall off the graph, but I know I need 3 points to make a nice straight line. Now, we're saying our solutions are greater than this line, not equal to. So I'm going to connect the line with dashes to represent not equal to. I'm not including the values on the line. I am only including the values that are greater than this line. So if I'm doing a greater than, I'm going to shade above the line. So that means all of this space, all of these coordinate points are part of the solution set. So I'm going to graph those points and show you why some of them are part of the solution set and some aren't. The first point was positive 2, positive 5 here. That's in my blue shaded space. The second point is negative 1, negative 7, which is off the graph, but not in the shaded space. The third point is positive 3, negative 4, which is just under the line, not in the shaded space. And the last point is 0, 0 at the origin, which is in the shaded space. So the points that live in the shaded zone are the solution points. They're part of the solution set. And the points outside of the shaded zone are not part of the solution set. Okay, I'm going to end this video and see what the emergency is for my husband who's calling me. I'll make a second video with more examples. Happy studying.